in example 1.12, it is given that electric field is like this for x greater than 0 and electric field is like this for x less than 0. Means this I cap shows that electric field is in x direction only, right? But for x greater than 0 means right side portion positive on positive x axis, the electric field is denoted by 200 I cap. I cap means direction is in positive x direction and magnitude is 200. So electric field in positive on positive x axis, it is in positive x direction and with magnitude 200 Newton per Coulomb. And for x less than 0 means for negative x axis, it is minus 200 I cap. Minus 200 I cap means it is minus I cap. Minus I cap indicate that the direction of electric field is in negative x direction and with magnitude 200 Newton per Coulomb. So intensity is same at both sides, but direction are opposite. In positive x direction, in positive x axis, it is in positive x direction, and in negative x axis, it is in negative x direction, and the magnitude of both is 200 Newton per Coulomb. So magnitude of electric field both side is equal to 200 Newton per Coulomb. Now it is given, consider a cylinder of length 20 cm and radius 5 cm. So consider a cylinder of length 20 cm and radius 5 cm. But we have to arrange the cylinder in this manner that this right side face is at x is equal to plus 10 cm and left side face is at minus 10 cm. So the center of the cylinder is at origin, right? Now we have to find first of all the flux through each flat face. Flat face means these faces. Now find the flux through these both faces, right? So now to find the flux, consider a small element here. Decide the direction of that is equal to ds. Now no need to consider small element. Why? Because at this flat surface the electric field intensity is constant 200 Newton per Coulomb. So it is uniform. So use direct the formula for uniform flux in the uniform electric field. Now the direction of this flat surface area, the direction of surface area of this flat surface is normal to this surface. So it is in right side, and the surface area of this left flat surface is in the left side direction, normal to this face. So first of all calculate the flux associated with first right face, that is equal to ES. Flux associated with right face is equal to ES cos. The E and S both are in same direction, so angle is 0. Electric field intensity is 200. Surface area, this is the circle, so surface area is equal to pi r square. So pi into r square, cos 0 equal to 1. So that is equal to 200 into 3.14 into r square. 5 centimeter means 0.05 meter whole square, right? So if we calculate, we will get answer 0.05 into 0.05 into 3.14 into 200, that is equal to 1.57 Newton meter square per Coulomb. This is the flux associated with right face. Now calculate the flux associated with left face, that is equal to ES cos. The surface area and electric field both are in same direction here also, so angle is 0. Now electric field intensity is 200 there also, and surface area also same, pi r square, and cos 0 is equal to 1. So this is the same term, so answer is also same, 1.57 Newton meter square per Coulomb. So this is the flux associated with a left flat face. Now find the flux associated with a side of the cylinder, means this curved side. So at curved side the direction of electric field is different in right portion and left portion. So consider a small element here. So the direction of that element ds in this direction, and electric field at here is in right direction. So the total flux associated with this flat face means surface of cylinder, that is equal to integration of E dot ds. Integration of E dot ds means E ds cos theta. Why I am using this formula? Because the direction of electric field is different at both sides. So if you consider small element here, then the direction of ds is perpendicular to this flat face and electric field is in this direction. In both the element, the angle between E and ds is 90. So theta is equal to 90, substitute here. So cos 90 becomes 0, so whole term is 0. So no flux associated with this curved cylindrical surface. Now we have to find the net flux associated with this whole cylinder. So net flux associated with whole cylinder is equal to flux associated with left surface, flux associated with right, and flux associated with curved surface. So for left 1.57, for right 1.57, and for curved surface it is 0. So 1.57 plus 1.57 is equal to 3.14 Newton meter square per coulomb. So this is the net flux associated with this cylinder. Now find the charge inside this cylinder. The cylinder is closed surface, so use the Gauss law. According to Gauss law, the net flux associated with any closed surface is equal to charge enclosed by epsilon naught. So total charge inside the cylinder is equal to net flux into epsilon naught. So net flux is 3.14 and epsilon naught is equal to 8.854 into 10 power minus 12. So that is equal to 27.8 into 10 power minus 12. So 2.78 into 10 power minus 11 coulomb. So this is the charge inside the whole cylinder. So this is very important numerical for the examination.